How's it going, everybody? So in Blender, I whipped up some concept art of a new game I'm trying to work on. It's going to be a bonsai tree game, mostly in the low poly art style. Those are some low poly cherry blossoms I made. I thought they looked really pretty. Now, I could import these directly into the game, but my vision for this project is the players able to manipulate the tree meshes themselves to make fully customized trees. That's kind of the idea of bonsai anyways, is you customize your own tree with like wires, make it look all pretty and nice. So I spent about 6.5 hours creating a custom mesh script. This took way longer than I ever expected, and I only got something semi-decent. It doesn't look as good as Blender's skin modifier, but I think I got something decent. Building the mesh generator from the ground up was quite the challenge, since I knew pretty much nothing about meshes and how to code them. So first step was to make a basic cube. As you may be able to see, this is not very cube-like. It's got all the vertices, but every face is wrong. So making a single cube probably would have been easier, but I wanted to make the code more robust so I could have a list of points rather than an actual cube form mesh and having to control each one of the points. So I wanted to be like the Blender skin modifier. I eventually wanted the data structure to be binary trees. For people who do not know what binary trees are, they're linked lists that can have two children. So for anyone who doesn't know what a linked list is it's kind of like an array, but instead of using like one specified chunk of memory, they just point to an object that points to another object and so on and so forth. Arrays have the benefit of being able to index anywhere in the array at any time, while linked lists you have to go through each point one at a time. So linked lists, they sound worse in this case, but arrays are completely linear. Like, you can create branching systems for them, but it's nearly impossible. It's such a hassle, it's not worth it. There are some tricks, but I think linked lists will work in my case here way better. To get a better idea of what I wanted, I opened Blender again and looked at the mesh generated by Blender. So I used linked vertices and added the skin modifier to generate these trees, which is kind of what I want to do in my game. So I looked around, so it looks like it generates about 4 evenly spaced vertices with relative angles, so there's no harsh edges, so everything's evenly spaced. So then I thought to myself, Blender's open source, I'll just look at the skin modifier code. After seeing 2,000 lines of code, I closed the tab, and I'll just make a crappier version in fewer lines. What I learned about meshes are made up of vertices and triangles. When creating the triangles, the order in which you list the vertices really matters. Only one side of the mesh is ever visible to the camera, so if you can see in this clip here of small ant, is you can see through the wall on the one side and not on the other, so meshes only have one side that's visible. If you've ever clipped through a wall in game, you'll kind of see what's happening there. So if you go out of bounds, you still see the map. So when you want the outside to be visible to the camera, you want to list the points in clockwise order. For example, see the cube, you want to go 0, 4, 5 and 0, 5, 1, and then repeat this for all the other squares, and that will be visible on the outside. If you inverted those, then it would be visible from the inside, and you get this weird cube look. Once I got the basic cube to work, even with the offsets, it looked a little bit weird. The angles were all wrong. The angles should be at the connecting vertices. This is basic high school trigonometry. Good thing I'm smart and would never forget. Incognito here. Sokotoa. Alright, we'll look at a few images. I don't really quite know what's going on here. Videos. Khan Academy looks good. Okay, we'll just skip through the video a little bit. Triangles makes sense. Yeah, that's what I want. Opposite, adjacent, hypotenuse. Perfect, got it. And I'd also never forget Pythagoras theorem. Yep, I would never forget that either. After using my jogged memory, I should be able to calculate the perfect angle. I mean the perfect angle. Okay, now the perfect angle. Oh wait, I eventually got it. But before I show you, I want to show you the funny ones because I thought it was just like by a little hair. It was trying to, and then here finally we do have a good angle where it has the different scales. It goes in all different directions. There's no end caps yet, but it's all we kind of need. After getting all of the angles to work, I added colors and normal values and then made it so I could change the mesh in runtime. So you can kind of see that it's clipping there. So what happens is if two of the values are the same, the meshes flatten to each other, so then it becomes infinitely zero. So now it was the time to integrate the binary trees. And look, I made a bunch of modern art here. And more art and more art and more art. So okay, so what's going on is I figured it out where the left side was connecting to the top, so I fixed that edge. So now it kind of looks more like a tree, and then you can still see that the bottom's wrong and the end cap on the left sides don't work. So this took a lot of effort, where things were just constantly broken. I'm just kind of looking through the mesh here, but you can see that the bottom is connecting to the far left side. So the reason why is because it was, instead of taking the previous, it took the second highest number, and then finally we get the full tree here, but then you can see the angles are weird. So now I'm going to re-enable the angles by just uncommenting 2 lines of code. So uncomment those, launch it once more. You can kind of see the angles got all messed up. Like, it's slightly there, but it's wrong. I'm changing the next angle from what the current angle was instead of the previous. So then I'll launch it one more time. So you can kind of see that here it's still at square boxy look, and then we will go into the perfect angles. So this brings us to the end of the video. If you got this far, please like the video or dislike it. Subscribe, unsubscribe, ring a bell, unring a bell. You're an adult, you have free will. Even if you're a child, you still have free will. So please download my game. It's free on Google Play. I don't know. Thanks. Bye.